Next up, fractions. I think fractions really kind of get a bad rap. A lot of people, a lot of my students, when they see fractions, they kind of freak out and seem to treat them like they're this, Mount Olympus of math work. Like it's so hard and you'll never figure it out. And they're really not that hard. There's really not that many rules, and I think if you kind of understand what they are, it makes it a lot easier to deal with them. So again, like the other videos, if this is your first time multiplying fractions, this might not be the right video for you, but I am going to kind of break it down a little bit because I know that a lot of people really struggle with fractions. So this is kind of an overview of the sort of different kinds of things that you'll see when multiplying fractions. So we're going to cover a lot in this video, but we're going to do it in kind of, a bit of a quicker pace. So this first problem, we've got 2/5 times 3/7. Now the basic rule of fractions, all right, and I'm just going to write this down. Supposing I have a over b times c over d, and I'm just using random variables. Basically, the rule is you can turn this into a times c over b times d, right? And then you wind up with whatever AC is over BD, and then you would just simplify it and then be done with it, okay? So that's kind of the general. Now there's some tricks and there's some things you can do along the way to make things a lot easier for yourself, but that's that general overview of how to multiply fractions will work every time. All right, so if you don't remember cancellation or any of the other things we're going to talk about, that still works. So this basically becomes 2 times 3 over 5 times 7 because it's 2/5 times 3/7. Doesn't matter what order you put the 2 on top in. It could be 3 times 2 over 7 times 5. It's multiplication, so commutative property lets us move things around. So 2 times 3 is 6. 5 times 7 is 35, and they don't share any factors, right? 35's factors are 1, 5, 7, and 35, and 6's factors are 1, 2, 3, and 6. I mean, other than 1, they don't share any factors, and 1 doesn't really help us. So the answer is 6/35. That is your simplest form, and it's positive because we had a positive times a positive. All right. Negative 1/3 times 2/5. Same deal, guys. All right, so do your 1 times 2 over 3 times 5. Ignore your signs for now. All right, and you get 2/15. That is in simplest form. And then because you had a negative times a positive, that would give you a negative answer. All right, so just remember your integer rules for your signs. All right, next one, 2.5 times negative 1/4. All right, this is a mixed number. So we need to deal with this mixed number. Now, the easiest way to deal with this for me is to just turn this thing into an improper fraction, all right? And so to do that, you always take your whole number and you multiply it by your denominator, all right? So you go 2 times 2, which is 4, right? And then 4, and then you add this one to it, which is 5, and then you put it over the part. Now, the reason this works, okay, is think about what 2.5 is. Supposing I draw 2.5 and I say here's 1, here's 2, and then here's a half, right? Well, so what this is saying is, hey, I want to write this as a fraction of how many of these subdivided parts does it take. So you just got to take this and split it up into that many parts. So you would go, oh, well, we got 1, 2, 3, 4, 5, right? And the multiplication works a lot better than having to draw it out, because this tells you, well, if you have 2 holes and each hole is divided into 2, that means you have 4 parts into that. That's why you multiply that first. So anyway, 5/2 times negative 1/4. Now just multiply straight across, right? So you get 5 times 1 over 2 times 4, when that negative is out here somewhere, all right? So 5 times 1 is 5, 2 times 4 is 8, and then you have your negative. And just to remind you, you could think of it as negative 5/8. You could think of it as negative 5 over 8, or you could think of it as 5 over negative 8. They all give you basically equivalent answers. Same thing, right? So that would be your answer for that one, is negative 5/8. And usually I write it with it just out in front. Okay, 4 times 7/2. Now, every number can be written as a fraction, even if it's a whole number. And so the big thing to remember with these, with the whole numbers, is just put it over 1, right? Because 4 divided by 1 is 4 wholes. So if you put it over 1, then you just kind of multiply it out, right? And you go 4 times 7 is 28. 1 times 12 is 12. Now this one I can do some simplifying. So let's divide each of these by 4. I think that'll get us close. 28 divided by 4 is 7, and 12 divided by 4 is 3, and you wind up with 7/3. And then we have one last example here, and in this last example, let me check my signs on that last one. No, they were both positive, so we're good. All right, on this one, so we're going to ignore the signs, and we're going to think of 11/3 times 9/44. Now, we haven't talked about cancellation yet, and I want to talk to you about cancellation because it really saves you a lot of time. If you notice in the last problem, right, if I go back and I look at this, if I would have practiced some cancellation with this before I got to this point, I wouldn't have had to simplify it, because I could have said 4 goes into 12 3 times, and then 4 goes into itself once, right? So that's a real easy way to get yourself some time back when you're taking a test or a quiz or even just on homework, right? So on this one, we got 11/3 times 9/44. So there's this thing they call the bow tie method. Now the bow tie method is fine, right, for remembering that, you know, well, you can cancel this way, you can find factors and cancel this way, you can do it this way, and you can do it this way, right? But basically if you're multiplying something, you can cancel any way except laterally. So really you shouldn't even need this bow tie to think about this. So look at 11/3, look at 9/44, and then just kind of think about them sort of, all right, what are some things on top here that I know can cancel with some of these things on the bottom? Well, I know 3 is not going to go into 11, obviously, but 3 can go into 9, right? 3 goes into 9 3 times. So I would cancel that, and I would write 3 there. And then you have to figure out how many, whatever factor you took out of this one, you got to take out of the other one. So 3 goes into itself once. All right. And then 44, you would say, well, 11 goes into 44. I'm knocking the place over here. 11 goes into 44 4 times, and it goes into itself once. And then you just multiply once you've gotten it kind of simplified. 1 times 3 is 3, and then 1 times 4 is 4, and you get 3/4. Now, if you're really bad at that and you can't do that, here's the thing. You can still do 11 times 9 over 3 times 44. All right? Nobody's telling you can't do that. And you get 99, and then this is like 132. And then hopefully you'd realize that 33 goes into this 3 times and into that 4 times, right? But you'd have to do a bunch of screwing around to get to that point, and this cancellation thing's a lot faster. Oh, and by the way, our negative times a negative gives us a positive, okay? So cancellation is worth your while to practice and learn if you're not very good at it. Most mathematicians I know who are good at computing can do the cancellation. It's kind of important, you know. Speed helps. It's not the only thing, but if you're fluent with some of these tricks and that, it will make things a little easier for you down the run if you're doing difficult problems.